Hey everybody, this modified competition problem starts with a definition. Log base 2 star counts the number of times the logarithm has to be applied in order to get a value less than or equal to 1. And they use the word iteratively here. That's a programming construct, sometimes called looping, I guess. But the operation here mathematically we're talking about is composition. Okay, so we're asking how many times do we have to compose log base 2 with itself in order to get a number less than or equal to 1. Okay, composition, did I spell that right? Right. So how many times do you have to apply this function to the number 29 in this case, just kind of arbitrarily chosen, to get a value that's less than or equal to 1. And again, this is a counting function. It will return a natural number, like 1, 2, 3, 4, 5, something like that. Okay, so now let's take a look at a fact that obviously needs to be answered before we can deal with something like this. There's this correlation between exponentiation base 2 and log base 2. All right, so both of these are increasing functions. So they're absolutely equivalent. This is the exponential version of this logarithmic statement. Let's just do a concrete example. What if we did 2 cubed? Okay, that's 8, of course. That's certainly less than, 11, let's say? And that's certainly less than 2 to the 4th, right? Which is 3 plus 1 right here, okay? Now again, that can be rewritten as 3 is less than log base 2. And a lot of this stuff you could just estimate, especially with small bases like this, is less than 4. Okay, so again, a logarithm is an exponent. You see over here, 3 and 4 function as exponents. A logarithm returns an exponent. Okay, so this basically is going to get used repeatedly to get the job done. And also, since we're trying to get down to less than 1, do remember that for any logarithm, let's do log base 2 of, and I'll put it in parentheses, just that normally that's dropped. But this is equal to 0 since 2 raised to the 0 is equal to 1. They're equivalent statements. All right. So for any base, this is true. That's why you have an x-intercept of 1, 0 on any unshifted logarithm graph. All right. So anyway, let's get busy. Now the first iteration is pretty clear. 2 to the 4th is 16. Right, and then 2 to the 15th is 30, or 2 to the 5 is 32. All right, it's equal to 32 right here. Okay, so that explains this very first iteration. Log base 2 of 29 is between 4 and 5, but remember our stop condition is we need a value less than or equal to 1. So let's try our second iteration. And again, 2 squared is 4, 2 cubed is 8, right? 2 cubed is 8, which is explains, and 5 is less than 8, so 2 cubed is equal to 8. That explains where this 3 came from, all right? But now we're between 2 and 3, right? So we're getting closer, but we've applied the logarithm twice, all right? So this would be 2. The answer to the star question would be 2 if this was less than 1, all right? And if you carry on, 2 to the 1st is 1, and then 2 squared is bigger than 3, so that's how this happens, folks. And you see, you just continue on, and then you get this result about log base 2 of 1 equals 0 happening right here, going from this step to this step. Okay, so you see, we got our number. We iterated 4 times. Okay, so this is the second iteration right here. Third. And I'll go to the trouble to spell out 4th here. Okay, and so what that means, after 4 iterations, not surprising, the logarithm function always returns a smaller number. All right, and it didn't take long, just 4 iterations, to get a number less than 1. And again, that was our goal, is to get something less than or equal to 1, I guess. I don't know if you could ever actually get to 1. But anyway, so the answer to this question, log star 2 is 4. The answer is 4. And I like the problem, folks. This is a competition problem. It's not exactly. I changed it quite a bit. They worded it differently, and then they had They wanted the number of zeros and the actual number, or something. I just went for the number of iterations here. But you see, these high school kids have to acquaint themselves with a definition in the middle of the problem. All right, so this is a definition. Not many of us have seen this. I've never seen it until I saw this problem, right? You don't see this in a college algebra textbook, or probably a lot of your college teachers don't teach this kind of math. This is not the mainstream kind of math that you see in a college algebra or pre-calculus class. So the kids, they have to read this definition, figure out what it means, and then get an answer, And so the answer is fairly easy, but you got to make sure you understand the definition. It's a counting function, and it took us 4 compositions that had to be composed with itself 4 times to get a number less than 1. So that is the answer, and I hope you enjoy that one.